all the engine building people out there are like, keep your day job, Dwayne. And,
That's when they find out your day job is building engines.
luckily, I don't do the building. I do the choosing of parts.
What are we doing today?
So today we're doing by far the most exciting, interesting, awesome, and just, it's what everyone wants to do when they build a short block. We are going to file piston rings.
Okay. That's what you dragged me all the way out here to do? File
Yeah.
piston rings?
I mean, that's what best friends do, right? It's what buddies do, right?
Yeah, I guess you're right. So, all kidding aside, the piston ring and the gap that you have on that ring is one of the most crucial elements of a build. Next to probably bearing clearance, it's probably the most important thing in a short block. So it's very important that's not just close, but perfect.
Yeah, this is something you definitely want to take your time on. You don't want to be drinking a ton of coffee before you do this.
Or a ton of beer.
Yeah, you definitely want to be in a Zen state of mind. This is like the yoga of engine building, maybe.
It's one of those tasks that it takes as long as it's going to take.
Yeah.
And you just relax, do it, bring over a buddy, you can talk, but be focused on what you're doing because you can always take a little bit more off, but you can't put it back.
Yeah. And also, this is one of those things you need to be really honest with yourself about what you're going to do with the engine.
Absolutely.
A lot of people on the internet will go crazy with this, and you'll have a lot of debates, but you got to be honest with what you're actually going to do with the engine. So we're doing naturally aspirated, so the gap will be a little bit smaller than what you'd see on, say, a supercharged or turbocharged engine. But I am going to run this at high RPM, high heat for extended periods, so it will be bigger than like a stock naturally aspirated.
Well, and correct me if I'm wrong, but I think the piston alloy also plays into part what you're going to choose for your ring gap as well.
Yeah, so we got some nice CP pistons here. They're 2618. What that means is it's very strong, and the piston has some give to it. It's not brittle, but it does expand more than a normal piston. So that's something we'll take into account. And we'll go through all that with you when we get started. So why don't we get to it?
All right, I guess.
I'll buy the beer after. Okay, so we're going to start with cylinder number 5 here. When you file the rings, you want to make sure you keep it with its respective cylinder, obviously. So we put the ring in there. What I like to do is use a piston to kind of square it up. Push it in there, and then you can get it really nice and square to make sure you're getting a good measurement. You always want to check what it was when you first put the ring inside there. So I haven't filed this ring yet. This is a top ring, and we're going to check what it is. And this is a 10 thousandths feeler gauge. See, I can't pull it out now. It's got some resistance, so it wants to stay in that position. You can't pull it out real easy. You shouldn't feel much resistance when you got the right size. So that was a 10 thousandths feeler gauge. That means it's got about 9 thousandths. Now, a lot of people debate about ring end gaps. I like to follow what the manufacturer says. So these CP pistons said we should multiply the bore size by about 5 thousandths. So this is a 3.572 inch bore. And when you multiply that by 5 thousandths, you get 18 thousandths for the top ring. The second ring should always be bigger than the top ring. You don't want to build any pressure between the first and second ring. It will cause flutter at high RPM in particular. So what CP recommends is to add 4 to 8 thousandths to the top ring gap. I'm going to add the full 8 thousandths because I'm really going to be beating on this thing at high RPM. I want to make sure I don't build any pressure between that first and second ring. So now that we've got that initial measurement, we know we need about, what is that, 9 thousandths more. So we need to double that size. We're gonna use our ring filer to do that. All right. Okay, so I've got this top ring set up in the ring filer here. It's a pretty nice ring filer. It's a Proform unit. And the biggest thing here that I can recommend is make sure that this face on the ring here, the face that we're grinding, is set up square to the grinding surface. You don't want to grind that on an angle, because then you'll have one part of the gap that will be bigger than another part of the gap. So be really careful setting that up. This is tightened down. Now, I've zeroed it here on the dial indicator, so that's right up against. In theory, you could just take 9 thousandths off and then you'd be good. I don't trust it that much, so I recommend taking a little bit off, remeasuring, taking a little bit off, and remeasuring. You can't add material back on. This is something you need to take slow, so I don't just go for 9 thousandths. I'll probably take maybe only 3 or 4 and then remeasure it. So let's try it out. There's the switch.
2,000 years later.
Day 71. Still no contact from any humans, but I've completed the Oracle filing. I think I may escape this dungeon soon.
Nerd.
It's not like Castaway or something, right?
Yeah.
Oh, the rings are finally done. All right, let's put this thing together, or measure mains, or something besides doing this. Yeah, right now. Ooh, what do we have here? We've got some connecting rods and pistons. So this is the stock stuff. Whippy, whippy, whippy. This is our new hotness. Hefty, hefty, hefty. It takes a lot of it. No, actually, it's lighter than the other one. We're gonna prove it right now. So what we tried to do when we set this engine up was you wanna get something that's stronger than the stock stuff, but if you can, also lighter. So we're gonna show you right now. We're gonna find out how much this weighs. Okay, so we're gonna measure the stock crappiness right here. Let's see what we got. We got 1,122 grams. And then when we measure this, we don't have this thing fully assembled yet, so we're gonna put the rings and the bearings on here, and then we'll lay this. I don't wanna mess up those bearings, because we have to get an accurate comparison of weight with all the pieces. 1,090 grams. So it looks like we reduced the weight by about, 32 grams, despite the fact that it's stronger. That's really good news. So we'll have a lighter reciprocating weight inside the engine, yet stronger. That's best of both worlds.
So that's 256. That's what, a quarter of a kilogram that we took off the rotating assembly?
Yeah, and that stuff's, the big thing with the piston and rod is they're changing direction constantly as they go up and down the bore. So that's gonna take a lot of load off the bearing and also make the engine just feel a lot more responsive.
All right, so we got the crankshaft back from the machine shop.
Finally.
It seems like whenever you drop a crankshaft off, it takes longer than any other thing. You can get a block, board, machined, everything, but they take an extra 6 weeks.
Yeah, I don't know what it is about the crankshaft places. Maybe someone who works at a crankshaft place can comment and let us know why, but it seems like they're always backed up and they're always past due. I don't know what it is. They kind of got you because there's not that many good crankshaft places.
Well, and you can't build this without that.
Pretty important. I think they know they got you, right?
Yeah. So what are we doing today?
Okay, so we are going to, first of all, make sure all this works, but we'll explain to you guys what we did here. We did something a little unique. This is a stock Ford crankshaft that we had offset ground. So what that means is we had the crankshaft rod journals made smaller. But when you make them smaller, you have the option to actually change the stroke. So we made the stroke a little longer. We went from a 3.543, I believe is the stock 4.6 stroke, to a 3.68. So it's actually a pretty big stroke increase.
Bigger than the stock LS now.
Yeah, it's a pretty big stroke, and it's actually not that far off of what a stock Coyote stroke I think is. And What you have to do that is, we got a 6-inch small block Chevy rod, but what we had to do is we took a set of Stroker 4.6 pistons, and we actually had the top machined down. So this is actually 0.1, so 100 thousandths shorter than a regular Stroker 4.6 piston. So that did a couple things for us. It made the piston lighter. We started with a dish piston, and that took the dish out. So I planned this all amazingly, and it worked. And it also moves your ringland, your top ringland up. So we're at 140 thousandths down from the top. Now you wouldn't do this on a nitrous or a supercharged or turbo application, but on a naturally aspirated application, that's actually really good.
Now, most importantly for Dwayne, it allows him to use his speed hole rods, which he loves so dearly.
You were just waiting for that one.
I was just waiting for it.
Yeah, I am really excited about that. And as we showed you guys in the last episode, this whole combo ended up being quite light for the bob weight, and you'll be amazed how much lighter this crankshaft's going to be. We took a lot of material off of it. So let's see how this Frankenstein works.
All right, let's get to it.
All right, let's see what this crankshaft weighs. Getting 42.2 pounds. So I weighed this before we took it to the crankshaft shop to get it ground, and it weighed 44 pounds dead. So we removed 1.8 pounds from this crankshaft, which is a whole lot of weight from something that's spinning around at 7,500 RPM. If you combine that with the losses that we had from the lighter rods and pistons, this is actually going to get quite a bit lighter. So we'll give you a final number in a minute, because I can't do that mental math right now.
A lot of boring math later.
So how much weight is that in total?
We took, let's see, 1,072 grams, so 1.072 kilograms, which for those of you out here who like freedom units is 2.36 pounds of total mass out of the engine. That includes the rods and pistons and the crankshaft. Obviously the crankshaft was the big part of that, but the rods and pistons were nothing to sniff at.
So 2.36 pounds, that's like a Coors Light, it's a silver bullet. What does that actually mean when we're, revving this thing out?
So you ever driven one of those cars that just has that like snappy engine? Mm-hmm. You know what I mean? Like some cars have a big power number, but it's got sort of that like lazy revving, like a big block or something like that. But you just have one of those engines just like on it, snappy, wah, wah, wah. That's what this is going to do for us. It's going to be like we have a really light flywheel. Now, I already have an aluminum flywheel on this engine and a teeny tiny little crank damper, so this is kind of the icing on the cake. This will make it feel like a race engine. And if you ever work on race engines, like circle track engines, mm-hmm. that kind of thing, they sweat this weight a lot because it really helps the engine. They call it transient response, is like the technical term. And you can't really measure it very well on a dyno. So if you were to stick this thing in first gear and just floor it, it's going to respond much more rapidly. It's going to transition from say 2,000 to 6,000 RPM much more rapidly than something that has a heavy crankshaft.
So at the same pull rate on the dyno, we're not going to see any difference. But what if we were to go from say 300 RPM a second to like 700 RPM a second?
Yeah, so we could do that on the dyno. We could get a really fast ramp rate on the dyno, and you could show that, the difference there. It's really interesting. I've seen some dyno tests that have shown that, but I've never personally done it myself.
Put that on the to-do list. We're going to show you guys what we can do with that.
And that's why sometimes you'll see cars that you'll see tests on or drag strip times on. You'll go, how does a 400 horsepower car go a 10-second quarter mile? And it's this kind of stuff that really makes that difference. It's hard to quantify with normal dyno testing.
So you mentioned offset grinding earlier. What exactly is that?
So I went over it briefly. So everyone knows what getting your crank journals turned down is, right? So you wipe out a journal, you get it turned down to a smaller size and run an oversized bearing or something like that. Mm-hmm. So we did an extreme version of that. We took a lot of size out of the rod journal. I believe we took 200 thousandths, right around 200 thousandths of an inch.
Almost a quarter of an inch.
A lot, yeah. So that's where all the weight came from. That's why the weight went down a lot. So when you do that, you can take the diameter down on the same radius, essentially, mm-hmm. From the center of the crankshaft. But when you're doing that, you can also offset it. So you got your main down here, and you've got your rod journal up here. you can make it smaller and then make it higher or lower. So you could reduce the stroke or increase the stroke. We increased the stroke, like I said, to 3.68 inches. This is kind of an old school thing. This used to be very popular in hot rodding, but it's kind of lost popularity due to the, you can get those cheap Chinese forge cranks now for $0 essentially. But I want to do something really special and really different, and the stock cranks on these 4.6s are actually really good.
So this is like an OG stroker crank.
Yeah, this would be something they would have done a long time ago. A lot of guys in your stock and super stock and like circle track stuff do fudge it, and they'll do this kind of thing without telling anyone. But this is a really good way if you want to do a custom combo. Now, for your average person, they're probably not going to do this because I had to do some math and I had to find the right suppliers and everything for the pistons and figure that all out. But if you're willing to put in the work, this is a really cheap way to do this. Bonus, we're getting 14 cubic inches.
So now we measure this, and then bring them together forever.
Finally, yes.
Or at least until you put the rod on the.
No, we're yeah. Nice.
Until you blow it up again.
Thank you.
Until he breaks everything.
No mechanical sympathy, right?
None.
We're really gonna test
None
it.
whatsoever.
Yeah, let's get it together. I'm tired of talking about it and working.
All right.
Yeah.
Let's get to it. All right. So in order to measure, we're going to need some tools, right?
Yeah, so we went over at extreme length our Mitutoyo dial bore gauge here, but I mean, we actually said we had a micrometer, but I was mistaken. That micrometer was not small enough with our new fancy small journals, so we bought what?
I went to Harbor Freight and bought the cheapest, the only micrometer set that they have, direct from Big Rock Candy Mountain. Still has that delicious Chinese industrial smell to it, but the thing is, the quality of this doesn't matter. All it needs to do is just stay put, because that's what does the actual measurement.
Yeah, so what we're gonna do here is you take this and you measure your rod journal, right? So if you're measuring the rods, which we're gonna do obviously. So you're gonna get your measurement here, and then you're just gonna lock this down. How does it lock? I've not used this thing yet. Is it this thing? Yeah, there we go. I've literally never used this piece before. So whatever, you get your point here, okay? And then you zero the dial bore gauge using this. So you'll stick this in here, and on the dial bore gauge, you zero it so it shows a 0 reading. And then after you have it zeroed based on this, you're going to stick it, oh actually that's a rod journal. So you actually stick it in the rod journal and you'll measure the difference. So your dial bore gauge will show what your clearance is. Now, this isn't the best way to find the absolute value. So this isn't the best micrometer in the world. So we won't know precisely what this number is. We don't care.
Doesn't matter.
We only care what the clearance to the rod is. And when I gave this to the crank grinding shop, I gave them the rod and the bearing. So obviously they fit it. So we're gonna double check that. That's why it doesn't matter to have a quality micrometer for this particular.
There's some aspects where you do want quality tools. This just isn't one of them.
Yeah.
And then the other way that you can skip the expense from this is plastic gauge. And I think what we're gonna do is we'll kind of do maybe a rod journal, because that's probably the easiest. To show you guys kind of the difference between measuring it like this and with the plastic gauge. And hopefully there's no difference. I mean, I've seen 1,000 horsepower engines that were put together with plastic gauge. It works fine.
I've done it myself.
Yeah.
So we'll show you guys the difference. That's actually a really interesting point because, I get it. A lot of you guys don't have $400 to spend on a, dial bore gauge. And this isn't even the fanciest one out there. So, all right, we'll give it a try and take you guys on this journey of knowledge and learning.
All right, so what we're going to do now is we're going to install the bearings in all these and then torque them to spec so that we can get the proper measurement for the inside rod journal. Set this to what does SCAT say? These are the SCAT ARP 5740s or 8740s, 7/16, that's 63 foot-pounds.
Don't mess up my rods. Do you ever wonder why they named themselves Scat? Kind of a terrible name. Sorry, Scat.
Don't make them mad. They might sponsor us one day.
You're dreaming.
All right, that one's torqued. And now I'm going to repeat this 8 times.
Alright, I'm setting the dial bore gauge to that particular rod journal's size that I measured with the micrometer. This is a little difficult because you don't really have a guide. Just gonna have to move it around until you get that 0 point, which I now have. So this should be 3.
All right, so what did we find out whenever we measured?
It sucks, but I guess this is why you measure. So we got one rod bearing that's about 4.8 thousandths, almost 5 thousandths smaller than the other 8. So the other 8 only have a variance of about 3/10,000ths, which is really good. So those are all good, but we've got one that's, like I said, 4.8 thousandths smaller. This is why you measure. If we tried to put that onto the crank, it wouldn't turn at all. It would just be clamping the crankshaft. So I gotta order another bearing. I'm gonna check the number on that bearing and make sure it's the right one. I'm assuming it's wrong because I've never seen Mala's quality control be that bad. So I'm hoping it's just the wrong part number and we'll get the right part number. I probably should have ordered extra ones, my mistake. The crankshaft's pretty good. The journals are all pretty close. This back one here, the 4 and 8 cylinder journal.
Half thou?
4/10, it's about 4/10 difference. So I'm actually gonna order 2 1/2,000 smaller bearings just so we can try and get that one the same as all the other ones. I'm splitting hairs here. It probably wouldn't actually make any difference, but why not make it perfect when you can? So that's what we're gonna do. I'm a little bummed because I can't throw it together, but this is actually kind of a perfect example of why you measure instead of just slapping something together on a weekend.
You know why it's number 3, right? Because it's Dale Earnhardt. You're running Chevy rods and a Ford motor and he's upset.
Was it number 3 that I blew? I don't remember. It might have been. We could look at the head, couldn't we?
We could. It might be number 3.
Is it number 3 that I blew?
It's still grumpy.
It is. Looking at the head, I think it's number 3. No, it's number 2.
It's number 2.
It's
Okay.
number 2 that blew.
But
over here.
yeah, the ghost of old Dale Earnhardt is upset. You're putting Chevy parts in a Ford motor.
I'm kind of bummed, man. I thought we were gonna actually get to put it together, but I guess this is just my motor making good video. I don't know. Okay.
Well, we'll order the parts and we'll get back with you.
Yeah. All right. All right, I'm setting up the caliper. We're using the super old one because we can for this size, right? This old one seems to be, we've measured a few, it seems to be a little more accurate than the cheap Harbor Freight stuff. Go figure, right? Real American made quality. So we set it up and then we zeroed the dial bore gauge into it and we measured a couple now. So the first 2 are within spec. So the factory spec was what was it, Travis? It was like
0.11 to 0.26?
yeah, 1.1 thousandths to 2.6 thousandths. And the first one was at 2.2, second one was 2.3. So we're on the high side, which is where I'd like to be. That one is about, let me get the back side of it. You should always measure both halves of the bearing between the oil hole. This one is right at 2.6, so it's on the really high side. There.
Yeah, you can see inside the bearing there's 2 areas with the oil groove.
Yeah.
You want to make sure you measure on both sides of that.
Yeah, because there actually is design taper into those bearings. One will be different than the other. So keep the crank from knocking back and forth like crazy. All right. Now the back 2 bearings we measured on the crank. Crank's a little bit smaller on the back 2 journal, so we have to reset the caliper and zero the dial bore gauge. Let's do that. Let's see if that matches the back one. Those 2 are the same. Okay. So you can measure with the same dial bore gauge setting. Zero this thing. Alright. How far off is it? I think it's 2/10 off from the other mains, which is really, really accurate. Crank guy did a pretty good job, to be honest with you. Okay, 0. Alright.
And since we said that we would hold off exactly who that crank person was till we verified their work, who is it?
This was a company in the Detroit area called Crankshaft Craftsman. And I have to say, now that I've measured their work and I've seen their work and I've measured their work, I already said that, didn't I? I have to say, for the price, it was really, really good. And they were really cool guys. So I would definitely recommend them if you're in the area and you need some crank work done. They don't do custom cranks, they just do grinding and that sort of thing. So perfect for us little people, right? Leave us your best screw this engineer comment, right? When the engineer did something which made your life a living hell, like putting an alternator in the wrong spot, right? Like, who was that? That's one you always like to complain about, Travis.
Oh, the North Star. It's the starter is put. Actually, probably the worst one is that Bentley where they put the starter inside the bell housing.
Oh yeah.
That's probably truly the worst. Because you can pop a North Star intake in a couple hours, but you have to drop the entire transmission in an all-wheel drive Bentley to change the starter. So that's never good.
That one's 2.4.
Right on the money.
Yep. So why do we want to be on the high side? We want to be on the high side of these numbers because it's a high performance engine, and you know, we're going to be running it a little bit hotter. It's aluminum block. So yeah, you're beating on stuff, give it a little extra clearance for you. 2.2 thousandths on that one.
Alright, so now armed with that data, we can start slapping stuff together, can't we?
Yeah, we're in the clear, as they say, right?
So now we just got to put those piston rings. I know you hate piston rings. You don't want to have some Vietnam flashbacks. Got to put the piston rings onto the pistons and rods. Lube everything up nice and get everything in there to work at spec.
Cool. Let's do it.
All right, so everything's measured. Mains, rods, piston rings. Finally, I think that's it for this episode. This very long and arduous episode.
Yeah, if you guys sat through all this, you have probably more patience than I do. I'm tired of this. All right, let's be done.
Let's have the fun part.
Okay.
What's that saying?
Get smart, have really long episodes.
And I guess that means go fast. We'll see you later, guys.